Welcome learners. Today we look at nitrogen and its compounds. Subtopic is ammonia gas. We look at two things: laboratory preparation and industrial manufacture. Now, laboratory preparation of nitrogen, reagents required is ammonium chloride and calcium hydroxide. Condition required: heat. Now, equation for the reaction is calcium hydroxide plus ammonium chloride, arrow calcium chloride plus ammonia plus water. To balance the equation, place 2 where there is ammonium chloride, 2 where there is ammonia gas, and 2 where there is water. Now, note that generally ammonia gas is prepared by reacting alkali and ammonium salt. Now, let's look at drying and collection of ammonia gas. Ammonia gas is dried by using quicklime or fused calcium oxide. Then it's collected by airborne delivery because it is less dense than air. Note that ammonia gas cannot be dried using A. Concentrated sulfuric acid. Reason: ammonia gas reacts with sulfuric acid to form ammonium sulfate. Equation: ammonia gas plus sulfuric acid, arrow ammonium sulfate. To balance the equation, place 2 where there is ammonia gas. Now, P, anhydrous calcium chloride. Now, reason: ammonia reacts with calcium chloride to form a complex compound. Equation: ammonia gas plus calcium chloride solid, arrow calcium chloride dot ammonia. To balance the equation, place 4 where there is ammonia gas. The diagram below shows laboratory preparation of ammonia gas. So we place here the mixture of ammonium chloride and calcium hydroxide, where it is heated. The gas is formed here. It's passed through the calcium oxide. That is collected by airborne delivery because I say it's less dense than air. Now the flask here is landed. The reason: to prevent water that condenses on the cooler part from running back into the outer part and cause cracking. Next, we look at this industrial manufacture of ammonia gas. It's done by what we call ABA process. Raw materials: nitrogen gas. Source: fractional distillation of liquid air. 2. Hydrogen gas. Sources: from natural gas, from cracking of long chain alkanes, or electrolysis of brine. Condition required: temperature of 400 to 500 degrees Celsius, pressure of 200 to 500 atmospheres, then finally divided ion catalyst. Now, finally divided ion catalyst, the ion is finally divided so as to increase surface area for the reaction. Now, aluminium oxide is used as a promoter of the catalyst so as to improve the efficiency of the catalyst. Now, the optimum conditions required is temperature of 500 degrees Celsius, pressure of 200 atmospheres. Now, parts of the process of the ABA process include purifier, compressor, heat exchanger, catalytic chamber, and condenser. So the first part, which is the purifier, is used to remove impurities, e.g. dust particles, carbon dioxide, and sulfur oxide. Reason for removing the impurities is so as to prevent poisoning of catalyst. Now, part number 2, compressor. So the role of the compressor is to compress a mixture of hydrogen and nitrogen in the ratio of 3 to 1. Reason: so as to raise the pressure of the mixture to about 200 to 500 atmosphere. Heat exchanger. The role of the heat exchanger: preheat the mixture of nitrogen and hydrogen so as to attain suitable reaction temperature. It also cools ammonia gas formed. Catalytic chamber. What happens there? Compressed mixture is passed through catalytic chamber, where it is maintained at a temperature of 400 to 500 degrees Celsius. Then nitrogen and hydrogen gas react in the presence of finely divided ion catalyst to form ammonia gas. Equation: nitrogen gas plus hydrogen, arrow ammonia gas. Balance the equation, place 3 where there is hydrogen and 2 where there is ammonia. Last part is condenser. Ammonia gas is liquefied in the condenser and stored in cylinders. Note that unreacted nitrogen and hydrogen gas are recycled so as to reduce wastage. Now the flow diagram below shows industrial manufacture of ammonia gas. So the raw materials, which is nitrogen and hydrogen, enter the first part, which is the purifier. From the purifier, it is pumped to the compressor, where the mixture is compressed to about 200 atmospheres. Then pumped to the heat exchanger, where I say it is used to preheat the mixture so as to attain suitable reaction temperature. From there, the mixture is pumped to the catalytic chamber, where the nitrogen and the nitrogen react to form ammonia gas. So we have about 10% conversion. We have about 10% of ammonia produced, which is pumped back with the unreacted hydrogen and nitrogen to the heat exchanger for cooling. Then after cooling, it is taken to the condenser, where it is liquefied to form liquid ammonia, which is stored in cylinders. The unreacted hydrogen is pumped back to the compressor. Now, physical properties of ammonia gas include it's a colorless gas. It has a characteristic pungent smell. It is less dense than air. It is very soluble in water. Now, chemical properties. 1. Reaction with hydrogen chloride gas. Equation: ammonia gas plus HCl gas give you ammonium chloride. Observation made during the reaction: white fumes are formed. Reason: ammonia gas reacts with hydrogen chloride gas to form ammonium chloride gas, which is white fumes. 2. Reducing property. Ammonia is a reducing agent, so it reduces metal oxides, e.g. copper oxide and lead 2 oxide. Example 1. Reaction of ammonia gas with heated copper 2 oxide. Equation: copper 2 oxide plus ammonia gas, arrow, copper plus nitrogen plus water. Balance equation: place 3 where there is copper 2 oxide, 2 where there is ammonia, 3 where there is copper, and 3 where there is water. Observation made during the experiment: black copper 2 oxide changes to brown. Colorless liquid is formed on the cooler ends. At the end of experiment, a brown solid is formed. Reason: ammonia gas reduces heated copper 2 oxides to brown copper solids while self-oxidized to nitrogen gas and water. Example 2. Reaction of ammonia with heated lead 2 oxide. Equation: lead 2 oxides plus ammonia gas, arrow, lead plus nitrogen plus water. Balance equation: place 3 where there is lead 2 oxide, 2 where there is ammonia, 3 where there is lead, and 3 where there is water. Observation made during the experiment: yellow lead 2 oxide changes to gray. Colorless liquid is formed on the cooler ends. After the experiment, a gray solid is formed. Colorless liquid is formed on the cooler ends. Reason: ammonia gas reduces heated lead 2 oxide to gray lead metal while itself oxidized to nitrogen gas and water. Now the diagram below shows the reducing property of ammonia gas. So ammonia gas is pumped in here, the combustion tube, where you have either heated lead 2 oxide or copper 2 oxide, where now ammonia, if I place here copper 2 oxide, ammonia removes oxygen, combined oxygen in copper, so you remain copper here. So as said previously, observation made here is the black copper 2 oxide changes to brown. Then, because the ammonia is oxidized to nitrogen and water, water is formed here on the cooler parts. So you say this combustion tube here is landed so as to prevent the water formed here on the cooler parts here from running back into the outer part and cross-cracking. So the gas that escaped through this point here is nitrogen gas. So the physical test of the water formed, it boils at 100 degrees Celsius. The description of the test is say, heat the sample of water to determine its boiling point. It boils at 100 degrees Celsius. The chemical test for water is it changes white anhydrous copper 2 sulfate blue, or it changes blue anhydrous copper 2 chloride, it changes blue anhydrous copper 2 chloride pink. The description will be add 2 to 3 drops of the water, add 2 to 3 drops of water into anhydrous copper 2 sulfates. It changes from white to blue. Reaction of ammonia gas. The next chemical property is reaction of ammonia gas with dilute acids. If dry ammonia gas is bubbled through dilute acids, ammonium salts are formed. Example, when ammonia gas is bubbled through dilute sulfuric acid, ammonium sulfate is formed. Equation: ammonia plus sulfuric acid arrow ammonium sulfate. Balance equation, place 2 where there is ammonia. Example 2, when ammonia gas is bubbled through dilute hydrochloric acid, ammonium chloride is formed. Equation: ammonia plus hydrogen chloride arrow ammonium chloride. The next property is effect on litmus paper. Look at two situations. Effect on dry litmus paper. Now, ammonia gas has no effect on dry litmus paper. Reason: due to absence of water to form ammonium hydroxide. Now look at next effect on wet litmus paper. Ammonia gas changes wet red litmus paper blue. Reason: ammonia is a basic gas. Now the next property is combustion. Ammonia extinguishes burning substances, e.g. candle. Reason: ammonia does not support combustion. Now next is reaction of ammonia with air. We have two situations. You have the absence of catalyst, also called uncatalyzed. Equation: ammonia plus oxygen arrow nitrogen plus water. Balance equation: place 4 with ammonia, 3 with oxygen, 2 with nitrogen, and 6 with water. Now ammonia burns with a green-yellow flame in air and rich with oxygen. Now situation number 2 is in the presence of catalyst, e.g. platinum wire or copper wire. Equation: ammonia plus oxygen arrow nitrogen 2 oxide plus water. Balance equation: place 4 with ammonia, 5 with oxygen, 4 with nitrogen 2 oxide, and 6 where there is water. Now the diagram below shows a reaction between ammonia and oxygen in the presence of a catalyst. So you bring in here air or oxygen. This one is concentrated ammonia solution. This one is platinum wire, which is glowing. It's red hot copper wire or platinum wire. Now observation made in that experiment is hot platinum wire continues to glow without further heating. The reason: the reaction between ammonia and oxygen gas is exothermic, hence the heat produced sustains the burning of hot platinum wire. Brown fumes are formed. The reason: nitrogen 2 oxide formed reacts with oxygen to form nitrogen 4 oxide gas, which is brown. Equation for the formation of brown fumes: nitrogen 2 oxide plus oxygen arrow nitrogen 4 oxide. Balance the equation: place 2 where there is nitrogen 2 oxide and 2 where there is nitrogen 4 oxide. Now next property is reaction with water. Ammonia gas dissolves in water to form an alkaline solution called ammonia solution or aqueous ammonia or ammonium hydroxide. Equation: ammonia plus water arrow ammonium hydroxide. Note that the solution of ammonia gas in water is a reversible reaction. Reason: ammonia solution decomposes at any temperature to produce ammonia gas. Now, when dissolving ammonia gas in water, a filter funnel is used. Reason: 1. increase surface area for absorption of ammonia gas in water. 2. To prevent water from sucking back into the flask. Now, the high solubility of ammonia gas is demonstrated using fountain experiments. Now, the other properties include reaction of aqueous ammonia with dilute acids. Aqueous ammonia neutralizes dilute acids to form ammonium salts and water. Example, ammonium hydroxide reacts with dilute nitric acid to form ammonium nitrate and water. Equation: ammonium hydroxide plus nitric acid arrow ammonium nitrate plus water. Now, reaction of aqueous ammonia with cations. Aqueous ammonia is used to test the presence of cations in a solution. Observations are made when aqueous ammonia is added dropwise until in excess. Now, the first type of observation when ammonia is added dropwise in excess is no white precipitate is formed. The cations which are likely to be present there are sodium ions, potassium ions, calcium ions, or barium ions. The next observation is white precipitate is formed soluble in excess to form a alkali solution. Cation possibly present is zinc ions. Now, next observation is white precipitate is formed insoluble in excess. The cations possibly present are lead ions, aluminum ions, or magnesium ions. Next is a blue precipitate is formed soluble in excess to form a deep blue solution. Cation present is copper 2 ions. Next is pale green precipitate is formed insoluble in excess. Cation present is iron 2 ions. Brown precipitate is formed insoluble in excess. Cation present is iron 3 ions. Now, note that the precipitate formed on addition of a few drops of ammonia is a metal hydroxide. An example of ionic equation is zinc ions plus 2 hydroxide ions arrow zinc hydroxide, which is a white precipitate, or copper 2 ions plus 2 hydroxide ions arrow copper 2 hydroxide, which is a blue precipitate. Complex ions. Complex ions are formed when the precipitate dissolves in excess ammonia solution. Example, when excess ammonia is added to zinc hydroxide, which is a white PBT, a alkali solution is formed. Ionic equation for the reaction: zinc hydroxide solid plus ammonia aqueous arrow gives you tetraamine zinc 2 ions plus hydroxide ions. The complex ion there is tetraamine zinc 2 ions, which is responsible for the alkali solution. Example 2, when aqueous ammonia is added to copper hydroxide, which is a blue precipitate, a deep blue solution is formed. Ionic equation: copper 2 hydroxide plus ammonia arrow tetraamine copper 2 ions plus hydroxide ions. The complex ion there is tetraamine copper 2 ions, which is responsible for the deep blue solution. Now, uses of ammonia: used as a fertilizer, used in the manufacture of nitrogenous fertilizer, used in softening of water, used in the removal of grease stains, used as a refrigerant, and used in manufacture of hydrazine, which is used in rocket fuel. The next lesson, we're going to look at nitric acid, laboratory preparation, and industrial manufacture, then chemical properties.